Alright, looking at our last conic sections, which are probably the coolest of the conic sections because they're the most unique, are hyperbolas. And the hyperbolas are like two parabolas that are facing in opposite directions. Okay, and so this is very similar to the ellipse equations and functions, except there's a slight tweak in it. Okay, and hopefully you'll be able to see it right away. And so this is what a hyperbola looks like. Okay, so it's it's basically two parabolas opening in opposite directions. And here's the function for it. And the x squared over a squared minus y squared over b squared is equal to 1. So again, you see it's equal to 1, and you've got these fractions over a squared and b squared. So it's very similar to the ellipse, except it's a subtraction. Okay, so the subtraction means that it's a hyperbola. Okay, if it was addition, it's an ellipse. Subtraction, hyperbola. And so a hyperbola, our center is again going to be at x minus h squared and at hk, where it normally is. Okay, and then again, this AB helps us with graphing it. So if the x is first in front of the subtraction sign, this is what it would look like. It opens up along the x-axis. If it's the other way, so if the y is first, then it opens up along the y-axis. Okay, so it opens up and opens down. So whichever one is first, that's the side that it opens up to. Okay. Okay, so let's graph this one. So we're going to start in our center, which is 0, 0 in this case. Okay. Now when we graph this, we're going to do kind of like a box method for this. So you take the square root of the numbers on bottom. So here would be 4, here would be 3, and then you're going to do the same thing like what you did with the ellipse. Along the x, you're going to move 4. 1, 2, 3, 4, put a dot. 1, 2, 3, 4, put a dot. And then along the y, you're going to put 3 up and down. Okay. And now what we're going to do is that we're going to make a box. Okay. So this might be a little bit difficult to see. Maybe I should do this in yellow or color that's not much better, but okay. But as you see, we have a box. Now what we're going to do is we're going to draw diagonals that go through the corners of these boxes and through the center, and then have it continue on through the boxes. Okay. And so as you see, they should touch both corners, and then they go off in both directions. Okay, these are going to be our slant asymptotes for this. Now for our final answer, we're going to go, okay, which one's first? The x is first. So you're going to start at, since the x is first, we know it's going to open like this. Okay. So we're going to start at the green dot along where we opened up along the x, and we're just going to make a parabola that goes and approaches each side of that purple line that I drew, that diagonal that you drew. And you do that to both parts. And as you see, we've just drawn a hyperbola. Okay, so you kind of make a box, and then you draw the lines. The slant asymptotes are what they would be, and then you kind of sketch so it gets close around it. Okay, and since the x is first, we're going to open along the x-axis. So now let's look at the next one. Okay, so it's a little bit different. So as you see, this one, the y is first. So again, we're starting at 0, 0. Okay. Take the square root of 25, that gets us 5. So we're going to move along the y-axis 5, up 5, down 5. And then square root of 1 is 1. So we're going to move along the x-axis 1. And then we're going to make our box. Okay. So there's our box. Now we're going to draw a line, our slant asymptotes. Oh man, I should have made this one. This problem is very narrow. So it looks something like that. Okay. Hopefully you'll have a straight edge, so you're able to do this a little bit better than me trying to do this on a vertical surface. And now, with the y being first, we know it's going to open like this. So we're going to start along the y, and then we're going to open up both directions. So as you see, this is a very narrow opening for the function. Okay. And again, you're just sketching it. You want to make sure you put this box, you draw these lines so that you're able to see it, and then you just kind of sketch where the curve would be. Okay. So that's graphing your hyperbolas, okay, or hyperbolas. Hyperbola. Okay. So that's graphing your hyperbolas. Okay. All right, now the foci. Now, if you remember the foci of the ellipse, we went the larger number minus the smaller number underneath, and then that equals our c. Well, for the hyperbola, we're going to add them. So you just add the two numbers on the bottom, then you take the square root, and that's how far you have to move left and right. Okay. Now, if the x comes first, so if you have x squared over a squared minus y squared over b squared is equal to 1, you're going to use this first one. Okay. If you have y squared over a squared minus x squared over b squared, you're going to use this one. Okay. So if the x is first, you're going to add and subtract it to the x. If the y is first, you're going to add and subtract it to the y of your center. Okay. Whatever your center is, you're just going to add and subtract your c, so the square root of the sum of the two numbers. Okay. And you have to make sure you do the square root after. So looking at this one, okay, which number is first? The x. So that means we're going to add and subtract to the x, to the x value. Okay. So since we know our center is at 0, 0, since the x is first, we're going to add and subtract whatever we get to the x. Okay. So the y is going to stay at 0. And so now we're going to take our numbers underneath. 9 plus 25 gets us 34. So we would take the square root of 34. And that is our c. So our answer for our foci looks like it's going to be root 34, comma 0, and negative root 34, comma 0. Okay. So that's what we get as our answer. Now, if you were to graph this on a coordinate plane, okay, which I'm just going to do a quick sketch here. Let's see here. Over 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So it's going to open up somewhere like this, okay, approximately. If you notice your foci, the square root of 34 is around, it's just under 6. And as you see, the foci is somewhere inside those parabolas. Okay. So to check to make sure that your foci is right, if you were to graph it, it should appear inside those curves. Okay. All right, your IRAT. What you're going to do for your IRAT is just going to be the graphing of these. Okay. So just graph these two. Okay. Sketch the graph. Make sure they're opened up correctly. So whichever one comes first, that's the direction in which it's opening. So just graph these two. Make sure your graphs are to scale. Make sure they're done professionally, looking nice. Okay, don't just scribble and say, "Oh, look at, hey, I'm done." No, try to do the box method. Make sure your asymptotes are correct, and then go from there. Okay, so that's your IRAT for hyperbola.